Hello, and welcome to this stream about agent sensing in Unity. I'm doing this together with a class of students that might be sending some questions in the chat, but the chat will be off when you view this after the stream. So for my students, welcome, and I hope this will be useful to you. I think let's just dive right in. We're gonna look at agents and how to implement sensing. So that's sight, vision, smell, or touch, or hearing, well, and any sense you could think of in an environment that could be used for a game or another simulation. Yeah, I'm going to, I have 2 files ready and the rest will be done while as I go. Let's see, I can close this thing. Right, I've got Unity here, it's Unity Hub, and I've cleared it so that I can just create a fresh project. This is also meant for people who have never done anything with Unity. You can just yeah, there's a lot of templates. I'm not going to go into that yet. No, not today. I've got the current latest to 2020 long-term support version of Unity. That's always the best, safest one to use. There's also like a newer version available of Unity, beside the long-term support, but those are less stable. So I'd also always go for long-term support version. So that's what I'm doing now. Unity is basically capable of doing a lot of different things. You could go into like high definition render pipelines and stuff, but I won't go into that right now because this is about the logic. So I'm just gonna go for a simple 3D, empty 3D project. I'm just gonna name it agent sensing, and then let's see, create project should start that. And let me take the chat up here so that I can see that as well. All right. All right. This will take a little while, but it shouldn't take too long to set up a new project. When you set up a new project in Unity, I usually would add a lot of packages that that I have bought in the past to make a project and to make the editor more handy to work with. But I won't do that right now because I want to show you like how to do it without any extra help from paid packages and stuff like that. This is taking way longer than I'm usually used to. I guess the streaming isn't helping. Maybe this new computer is not so good for the streaming. Well, we'll just, you'll be able to skip this if you're not viewing this live. I won't say anything super useful, but here we go. Yes, there we are. All right, so default Unity settings might be the other way around, by the way, that you see the hierarchy on the left, but I would highly recommend putting the hierarchy to the right because it often requires dragging from the hierarchy to the inspector. Well, it might be a lot just to see all at once, but I'll just quickly go over what everything is. The scene view is where you see the scene, all the current objects that are in the game scene. The hierarchy shows that as well, but then as a tree view. And in the inspector, whatever you select, either in what you see here, the main camera and the directional light, either in the scene view or in the hierarchy, whatever you select will become editable in the inspector. That also goes for things that you select in the project view, that's below here. If I, for instance, select the scenes folder, you can see that nothing much can be done with that, but then there's the sample scene in there. Also not much can be done with that, but you'll see later that you can edit some stuff from files that you put in here as well, especially things that you import like textures. And then there's the game tab here that shows what the game would look like from the camera that you're using at this point. You can use multiple displays and set specific resolution, stuff like that. And then last but not least, there's the console. I always use a Pro console. That's like on Editor Console Pro because it has a little bit more info, but this is basically gives you a debug, error, and warning messages that you can click on and get more info here. And then you, if it's a thing that's an error from a script, for instance, then you can double click it and go to the position in that script. Talking about scripts, you edit scripts with Visual Studio or another tool that edits C# scripts, but that's what we work with is C# and some shader languages and some other stuff, but mostly C#. And yeah, so basically you use that. First thing I am going to do though is, let's see, I'm going to get to the package manager and I'm going to do one thing. I'm going to install one thing from the asset store. I'll actually show there's a asset store. If you click this and you haven't set it up, then you will get a message that you have to go to the asset store online, which is here. And if you there search for one thing that everybody should use, and that's called autosave. Yeah, recent search, you see. Oh, there we go. Wow, too much. Autosave. There's a couple of autosave tools. Some are like meant for the game to save stuff, but actually it's you want to save your scene automatically. That's basically the thing. And there's this free one by EM, and that works fine. So that's the one I'm going to install now from my huge list of tools that I have here. But there it is, autosave scene. I can re-download it. Usually you download it first and then you import, but I'm just going to import now. If I import this, it will give me an option in the menu. Oh, thank you there. Boom, boom, boom. This takes longer than I'm used to again. Well, that's the streaming, I guess. I should do it with my stream capture box again. Didn't used to. Now, in tools, you see autosave free. It has some settings. That is actually one of those things that show in this inspector. Autosave is now on and it saves every 5 minutes. If you don't do this, you'll lose some work every now and then because Unity is a complex tool, so it will crash some every now and then. Now you see that there's automatically 3 folders in here already in my assets, which is where you put everything that you need for a project. And those are plugins and autosave. They are just from the autosave system. And then scenes. I'm actually going to make a few more folders. I'm going to rename scenes so it's always at the front. I don't know. I mean, for this project, it's probably not that important, but yeah. For projects that use multiple scenes, it's always handy to have that at the front. That's just whatever you like, but that's how I do it. And then I'll make a scripts folder to put the scripts in, because if you don't do this, it will quickly become a chaos. And then I'm gonna make a folder for prefabs, a folder for models, a folder for images, which you could also call textures, but sometimes you have like UI images as well, and they're not really textures. So let's think. There's materials. So if this is already first thing that I do, because I want to set it up so that it doesn't become a chaos and then you have to reorganize it. It's much easier if you do that up front. So now we're going to get into agents. So let me first grab something else that I have ready, and that is a little explanation of agents. So what is an agent actually now? Well, let's first look at the definition. Etymology, what does the word actually come from? It comes from agere in Latin, which is just doing, to do. And agent just means something or someone that produces an effect, and that's basically it. So it's an action. It also comes from the same stem of words, action, agent. We are going to work with a little bit more further defined version of this, because we're talking about an agent in software, and then we're talking about intelligent agents often. And then we say it's an entity in a program or environment capable of generating action. And then this is a definition also used often. An agent uses perception. An agent uses perception of the environment to make decisions about actions to take. So you see I've colored those 4 words: agent, perception, environment, and actions. We'll put that into a little bit of an overview because those are the things that we'll need in our system. So let's put them somewhere and then make it a logical whole. Here is a thing that I've made in the past for my own studies. It's you got the environment and you got the agent. So basically there's a perception and actions, and somehow we have to link that all up. What we need for that, and that's the thing that we're going to program today as well, are sensors. So the things that actually give information from the environment to the agent. So we call that collecting stimuli. Just like it doesn't have to be programmed. So you can actually use this for any agent. It could just be a human in nature or an animal or whatever. You collect things from the environment that you could call stimuli, like a light or a touch or whatever. So anything you can sense. And you translate that gets translated into things that you have perceived, and that is often called percepts. So basically you collect these kind of like facts, or well, things that the agent views as facts from the environment, and those are the percepts. Like I've seen I've seen a dog at that location and it was brown, something like that. That can be info that you perceive. Or I felt a hard touch and it was cold. Stuff like that. From those percepts, the agent has to have his own internal representation of the world. And that we can call state or world, or there are different terms for it, but I'll call it state for now. The percepts, you have to somehow interpret the percepts and remember them to have a internal representation of the state of the world, including the agent itself, but anything in the world. So based on that state, you actually will be able to decide on actions. So there's a state, and however you decide, we're not going to talk about that now because we're talking about the perception part, but there's lots of different ways to do the decision process. Based on the state that you have, that it includes all the perception and everything you know and think about the world as an agent, it's decided, like, let's take these actions. And then the cycle will be complete because the actions will then act on the environment where they will have some kind of impact. And that impact will translate into changes or things that other objects get influenced by, potentially. So in terms of architecture, if you want to see this as a specific part of it, then you could say like there's sensors, and from the actions you have actuation. That's the presence you have could also already be something like some other agent can see you, but also actually moving stuff around or destroying things, making things, everything you can think of that changes the world. So those actions will change presence or trigger actuation, and the actuation will act on any object. So this goes for the real world, and this also goes for a game engine. If you translate this to a game engine, then it's simply any object is an object in the game engine, and the agent is also an object in the game engine. So whether we're talking about game engines or real world, it's actually also always the case that, of course, the agent itself is one of the objects. So you could have an internal representation of the agent, but you could also make that something that the agent has to perceive. So if something internally changes, then you do that with the same sensors. I'm not going to go further into that, but there's a lot of ways you can implement that. All right, so for now, that's, I think, enough about agents to start, because now we can just go and look at those sensors and see how we can implement them in Unity. So let's start with some agents. well, let's see what I want to do. I want to create something that represents an agent. So I can start here by, I want to create a 3D object, I'm going to create a capsule. That always looks nice. It's kind of like the most simple form of kind of humanoid-ish, but like very, very abstract. They are often used for game prototyping purposes. Now, this capsule will have to stand on something. I don't like it being like floating up in the air. So what I'm going to do is I'm going to make a terrain. You could also make a plane. The plane is really small. That's nice, but I'll have to scale it up. But what I'm actually going to do is make a terrain. And a terrain is huge. By default, it's 1,000 by 1,000 units. And in Unity, you could view a unit usually as a meter. So this terrain is huge. Let's see here. You can see terrain width and terrain length. They're 1,000 by 1,000 units. What I'm actually going to do is I'm going to put it to the middle, because now it starts at 0, 0 and goes out to what you can see here as positive X, positive Z. Unity has the coordinate system. You can see always RGB for X, Y, Z. That's also in any 3D program, by the way. But the Y-axis points up. That is actually convention from this side, like X and Y are the screen. So then starting at 0, 0 would be something like this. I see that my key, it is working. Oh, okay. All right. So basically I want to move it into the X and Z direction minus 500. So that's what I do here at the transform of the, not of the capsule, of the terrain. So the terrain I'll move to minus 500 and minus 500. Now I've got like a huge area for my agent to sit on. That's nice. I don't want it to run out of space, because that's not what I'm worried about right now. All right, so this agent is now kind of in the floor, so I'll move it. I know by experience that this thing is too high, so I'll move it one up and then it's touching the floor. Some other things that I'm going to do is set up a nice camera angle. That's super easy if you're not interested in what it exactly represents, because it can just move around in this view. If you're not used to it, of course, it can take a bit of practice, but it's like any 3D view in any 3D program. And if I got a situation that I like for my camera, I could just click the camera and go to Game Object and align with View. So then my camera preview, you can see here, the game view matches the scene view. And now if I change things in here, my game view will still have the camera set up like that. And you can see it here. It's not very thick, but you can see those lines. The camera is like there, and it's not going to move anymore unless I move it, which I'm not going to. So right now I'm going to use one extra feature here, and that's locking it. Now I can't select it anymore, and I actually don't even want to see it. Oh, oops, that was too high. I don't actually want to see it, so I'm going to hide it. The same actually goes for the lighting. I'm really not interested in lighting at this point, so I'm just going to not see it. I actually don't have to do that. It's extra lock. What I am going to lock, though, is the terrain. I don't want, if I select stuff, I can do this. That's fine. But somehow I could maybe accidentally select the terrain and do stuff with it. I don't want to do that, so I'm going to make it unselectable. So now the terrain is there, but I can't select it. That's just some basic Unity environment tips. Now I don't know about you, but I'm pretty much getting almost like a headache from this texture here. So that's one of the things that I had ready here is a little green, actually going to close the hub, a little green texture. It's really literally very, very small. I think it's 4 by 4 pixels. Yes, there we go. You don't really need something large if it's just one color. So I'm going to drag that into images. And then we've got a green texture here, and I can actually put that on the terrain. Why am I not just saying the terrain can be this color or that color? That's simply not possible. A terrain always uses a texture. So I'm not going to go over that too much, but here with painting, I can create a texture. And then I have to get a layer. I'm not going to go all too long on too long about this, but now I've got a nice, more calming background there. All right, so you see here there's new layer now in images, which I don't feel appropriate. This is a terrain layer. That's actually a material. So I'm gonna put that into materials. So we got a terrain here, which I'm never gonna really need to look at again, but you could use it to do all kinds of cool stuff. Hold on. I could like make an actual terrain here with stuff, with painting, but let's not. I'm just gonna, I've got it locked now, so I can't accidentally select it, and it's just a nice color green. An interesting thing, by the way, what I just did, like I could find this thing and I couldn't find it, for instance. If I double click it here, then I'll just zoom right to it, and the same goes if you press F for focus. Right, so this capsule has a few things here that you can see. These are called components. The transform, just what I already said, it determines where the thing is and what rotation and scale it has. Oh, oops, yes. But it also has a renderer and a mesh filter, which just determines what shape it has. I'm not going to need them now. I'm going to collapse them so that I have space to put more things on this this object, because this object is what's going to be my agent. I can change the name of this. I can do it here or there. Oops. So I'm going to call this thing agent, and that's going to be my agent. Right now I'm doing Control S, but I sometimes don't do that. But I already have some autosaves here. Also, what I'm going to do is, it's called sample scene. I don't like that much. My scene, I'm just going to change the name to sensing test or whatever. Sensing test. Now it says that this was open, and it was opened as a different name, so I'm going to reload it. It doesn't do anything, but just that. All right, here's the agent. And then let's see. What I'm going to do now is maybe add some obstacles and some enemies. Just let's do that, because we have to perceive something. So for enemies, I could just create more capsules. Another capsule, and that's an enemy. So you see, if you create an object, its name will be automatically selected, so you can change it. And then this is exactly at the same spot as the other agent, but if I move it, you see, there it is. And now I will actually use this move thing, and then I'll use the square here to only move it in X and Z direction, so it stays on the floor. So I've put one there, and I'll duplicate, Control D. I'll put one here, and I'll put one here. But this is actually not so nice, because now I don't know what is what. So I'm going to go back a little bit, and I'm going to give this enemy, I want to give this enemy a different color from the other agent. Well, you see in the mesh renderer, when you go back again, you see here materials, and down here you've already seen, even if I close this, what material it has. It has some kind of default material. If we want to give it some other kind of color, we have to create a material. So I'll give it red. I'll make red for the enemies and black for the for our NPC, for our agent, I guess. So what I'm going to do here is make it black. Not so hard. Make this one red. And you can use lots of other options like smoothness. You can see that change, metallic, and that way it's going to change the look of the object. Basically, to change the material, I could just drag it onto the object. So that's also very handy. Now, if I want to make more enemies, I could just copy this one, but there's actually a very interesting and handy feature here that I have to go into now, and that's prefabs. If I want to make multiple of the same object, I want to actually make some kind of like blueprint, they call it in some that's what they call it in in Unreal Engine, and in Unity they call it prefab. It's kind of the stamp that you use to make an object. It's a recipe, and basically if I drag an object out of the scene into whatever folder, it will create a prefab, and now this becomes blue, noting that it is a prefab, and then you get an extra thing, extra line here. And I'll show you what the power of a prefab is. I'll make some enemies. So this is one thing that I really don't like that much. Actually, I should, because I am making multiple, I should already rename this one 1, because then when I copy it, the next one will be 2. You can actually define what numbering scheme you want and stuff like that. But okay, let's see. For instance, if I want all the enemies to be bigger, like twice as big, like that. If I now added one enemy, the others won't change. But I have here the overrides thing, and it shows what I've done to the prefab after it was a prefab, and I've changed in the scene. If I apply it to the prefab, boop, all the others become large as well. You see there's one thing that doesn't change with the prefab, and that's the position. So it doesn't move up automatically. I could also, instead of just Unity has, by the way, up to 100 undo levels, so that's also handy to know. You can't go back like infinitely, so definitely use proper version control. Yeah, so if you can also change the prefab from the prefab itself, and then it instantly changes in the scene, because it saves that on, and those are referencing this. Well, I'm going to go back, and this is just my enemy prefab. Next thing I said, I want to make some obstacles. Just let me make some cubes. This is a small cube. I'm now going to do a different way of resizing. I just did it with the transform there, but you can also just use the tools that you have, and I'm gonna make it exactly 2 high. That's just a bit easier to, no, let's make it 3 high, and then 1.5, so that it's actually on the floor. But other than that, I can just resize it wherever I want. So this is now intersecting with our agent. So actually gonna call this obstacle 1 and put it somewhere. So right now it's between the agent and that enemy, and I'll add some more obstacles. Maybe I don't know if I want it later, but I'm guessing I do. I'm gonna create a prefab for that at first. I can also create instances of prefabs by dragging them into the scene directly, or dragging them into the hierarchy. If I drag them into the hierarchy, it will actually take the transform the position of the last one, because that is saved in the prefab as well. But I'll actually reset that in the prefab itself. You see that nothing changes with that one because it's just copied when I place it in. But now I've got 2 obstacles, and you see like that, it works. But also when you copy a prefab, I duplicate it, the new object will also still reference the prefab. All right, so I've got some obstacles, and I've got some agents. An agent and some enemies. Let's keep it simple. And this is basically my scene now. Now there's the next thing to consider is what to do with the with the agents sensing. So that's actually what we came for. So this was kind of like an introduction how to build a scene in Unity, but now we're getting into the scripting. For those who are not familiar with C#, what we're going to do here is create C# scripts. Scripts is actually just a term for like a class that is compiled into the program. I can just use add component for that and type any name I want. So for instance, agent, which I had already typed. And then apparently there's a navmesh agent component that I could add, but also I can choose new script, and the script's name will be agent. So what I'm going to do now is create that and add it to this object. What you see then, this agent script, if I click it, you see where it is. It's put in the root of the assets folder. I don't like that because I want it to be organized. And I put it into scripts, and then it's organized. You see here in the lower right corner, oh, it's not scaled, so that's, you see a tasks progress thing that shows you when, for instance, a script is compiling. I'll just move it back to show you that. It should be compiling now. Oh, that's actually, background tasks is quite clear for that. Close tab. But this indicator will show you while it's compiling. So if I move this, then it has to recompile. You see it there. And then it's done. This is one thing that I actually want to get rid of, because my console, I want to keep it clear and clean. So I'm going to go to my package manager, and because it says there's an update, I'm going to go to the packages that are in the project, and I see here that there's an update to this one. And I'm updating it, then it will recompile the stuff. And version control, that is for Plastic SCM or Collaborate, which I'm not using, so I'm removing it. I could also remove the editors that I'm not using, but I think I won't do that for this stream specifically, because I might share this test framework. I always keep that in because you might want to run some tests in the editor. All right, then we'll continue, and now there's something that I always here check. I mean, I think it's on by default, but clears the console whenever you press play or whenever you build. And I also can click clear here so that I don't see the old error messages there. This terrain asset is actually not in a folder, I see, so I'm gonna put that in models. It's not strictly seen, it's not a model, but yeah, so I was talking about scripts. C# is a language that is strictly typed, so it's strongly typed, I mean, and it has a precompiled instruction language that is then interpreted by an interpreter. Unity actually has an extra thing where they precompile that instruction language into C++ and then compile the C++ into an actual executable, so that your code will run in the engine, which is also written in C++ at the maximum speed. But we don't have to talk about that. It's just so you know that your code is written in C#. You see it here already. And I've got this agent script now. I actually don't know what I'm going to do with it yet. Maybe I'm actually first going to create a different script, because I want to start with some kind of vision. Perception, but let's start with sight. So I'm going to remove this one for now, because I don't want any non-functional. Well, actually, no, let's just keep it on there. I'll add sight as a script. I could call it vision, but I always like sight because it's the same amount of letters as smell, touch, and smell, touch, and sound. So that's why I call it sight. Create an add, and then we got a new script. Immediately gonna put it in here. Another way to do this, by the way, is go into my scripts folder and actually create a new script here. So I can create a C# script in the folder. For instance, I could call it Modality, which I want to have later, and then it's already in the right folder. It's just not on any object yet. So this agent object here has those two scripts on it. So those are components on the object. And the other thing that it has is a collider. That's something that we're gonna need. That's from the physics engine. It enables us to use any physics that we want. We could have a full physics simulation running, but we're not gonna do that. We're just gonna use it to collide rays that we're gonna shoot out through the scene to see, for instance, if this agent you want to see if it is able to see the other agent. Well, you know that it's not able to see that one. It is able to see that one. If it's pointed in this direction, it won't be able to see that one. If it's pointed in this direction, the other way. But you want to also see if it actually collides in the ray that goes from this object to that object, if it collides with any other obstacles. That's what we're going to use the physics engine for, and that's what these colliders are for. So that defines the shape of the object. You see this green bit here, when I turn it on and off, you see it more clearly. That is the shape of the collider of this object. So does the obstacle. It has a box collider. You can see it a little bit harder. Well, actually, nice thing to do, make a new material. I'll create a, let's just still call it brown for the color that it's gonna have. And then we can see it a little bit more clearly. And this obstacle, I'm gonna apply the things that I just did to the prefab so that all the obstacles will be that. And now you can more clearly see the shape of the collider. You could make a collider with a different shape than the object, for instance, much bigger or whatever, but we're not going to focus on that for now. Right, so I've got my obstacles and I've got my, I don't want this to be shiny, by the way. Whoop, there we go. I've got my obstacles and I've got my agent and my enemies. And now I want to check, I want to write some code that checks for this agent what he sees. And what I'm going to do is go over those things. Now, we said that we have the perception and then the internal state, and then you have the actions. I'm going to go over the perceptions and the internal state, and the actions is something that you can then implement on that. So basically the thing that we want to do is create some kind of vision. So we've got the script here and this side script, and it's still empty. Oh, it's opening another Visual Studio. That's super handy. I thought that would be handy that I had it already open, but there we go. So you see here a couple of things are happening. You see the solution here that is has all the folders in there with scripts. I don't really need that now, so I'm gonna simply close all these so that's just a bit more clean. Because I'm only gonna use Visual Studio as an editor. So you have these two programs open, Unity. There's also plugins for Unity that do the editing in the editor, but since you need a lot of space to do code editing anyway, I've tried them in the past. I just went back to Visual Studio because it's very powerful. You see here a couple of things that are automatically done, and also maybe a few things that are weird for you if you're not used to C# and .NET. That is like the naming. These methods are named with a capital. Well, that's a thing that is that's something that C# does. It's a convention that we have. Classes are also capitalized, and then another thing that is capitalized in C# that is not in other languages, public variable. So if I would have a public int, I don't know, number, whatever, you wouldn't do it like this. Actually, at Unity they do. So it's not 100% everywhere, but in .NET, which is the origin of C#, because that's Microsoft that made C# and that's where it came from. There you always give public variables a capital. So that's what you're gonna see here. And for private variables, default is private, so you don't have to do anything there. This means a private variable, and then you would see them definitely not capitalized. Sometimes people use an underscore, just like in Python, or in C++, that's also very common. In C# you see this less. I tend to not use it in C# as well. Something else in no, I think I said everything about C# that I actually should say right now. All right, so let's start. What do we need for this? It's a site, so I need a direction. Well, fortunately, in Unity, objects already have a direction. So this agent is facing in that direction. Let's change that a little bit. You see here the rotation handles. I'll change it to face another direction. It's not super clear where it's facing, so that's why they added in some recent version a combo. You can move, scale, and rotate in the same thing, and now I can actually see where it's heading, where it's facing. The blue axis, that is the z-axis, moving forward is the convention that is forward, just like x and y are the screen and the z faces forward. So the forward direction for any object in Unity is the blue arrow. So RGB, B is the Z axis. So now I'm having the agent face this direction, so if he has normal vision, he should be able to see that enemy, enemy 2, and not enemy 1, and also not enemy 3 because it's behind him. So let's make sure that he does. So I'm gonna go first into what I want him to see, and for that I'm going to create a visualization. This is, you could do this any order that you want. Oh yeah, I also always like to take off private because it's more clean. Just what my personal preference. You can leave private on if you want. But I'm taking it off because default is private in C# and it's just shorter. There's this thing called onDraw Gizmos. Well, you see these things here that you can use to view colliders or manipulate objects with. Those are called gizmos. Actually not that one, but for instance the colliders. You can turn them off and on here, and they give you extra information about an object just in the scene view. In the game view, you will never see those. So they will just be for the person that is editing the game. So what I can do here, and I like to do this, is first visualize what I want to get. And there's, you have to know what you're doing, but I know what I'm doing here, so I'm going to show it. I'm going to set a color, and let's just say color.red for now. And then in that color, I'm going to draw something. And the thing that I want to draw is what the agent sees. That is, for that there's actually a handy function called frustum. A frustum is what a camera sees, so that's the thing that if I turn it back on here, you see that thing here, those lines. They're maybe not super clear, but those are the frustum of the camera. So I want that same thing actually for the agent to see what he sees. So I'm gonna draw that. And what do I need? It draws the frustum using the currently set metrics for its location and rotation. So I'm going to have to use a matrix for that. Then you need the apex, which you can just set to vector 3.0. I'm going to need a field of view. Well, that's how wide the angle of view is. So I'm going to make a class variable for that. So let's call it angle. And I'm going to create that here. Say float angle. Let's put it at 60 degrees or something at first. And then what else do I need? I need a maximum range. So I'm going to call that the view distance. Distance. And then I need a minimum range. That's where it starts to draw that thing, like where the thing is, the agent shape right now is 1 wide, so I'm gonna start at 0.5 using the F there. That's a convention, by the way, for C# to indicate it's a float number, and otherwise it will be a double. So that's you don't want that if you don't need it. And then the aspect, and it's the aspect ratio, that's the width compared to the height. So if I want him to be able to view like a normal camera / eyes side would do, I would make it at least twice as wide as it is high. I'm actually going to make that into a variable as well. So I've got the distance in the aspect variable. So let's say distance. I will make it, I don't know, view 20 ahead, and then aspect, I will do 2, like I said. So now I'm drawing this, but it still said I have to use the current gizmos.matrix. I'm just going to do that because that's really something that you have to look up if you want to know what I'm doing here. Matrix 4x4 dot transform rotation scale, and then we can use the transform of this object dot position, transform dot rotation, and transform dot scale. I could also do this differently, but it doesn't work as well. So anything you put in onDraw Gizmos has to do some calculations, but you don't have to worry about the performance of that because it's only in your editor. Let's see what it does now. there we go. So you see that this code is, when I save it in Visual Studio, it's automatically compiled once I open or go back to Unity. And you see here that that frustum that I wanted is actually drawn. Now, what if I want to change this a little bit and I want it to be like a smaller angle, farther away, stuff like that, different color, and I want to just change that? Well, I could go back to my script and change it here, but there's actually a nice little inspector here that actually has nothing visible here, and I want them to be shown here. So site will show the angle, the distance, and the aspect. Well, there's two ways you can do that. I can make this public, which is actually a bit weird, but also not. It shows that you can edit it from outside this class, which is also in the editor. But actually I don't want to do that always. What I want to do is add serialize field. Serialize field, it just means that Unity will serialize this field. Actually, that means it will save the value of this field with the object. And that also means that it appears in the inspector. So if I add this to my variables, now you will see that this is the default value, but that it always will load that for each object in the scene file. And here we go. There we have angle, distance, and aspect. Now if I change these here, I can drag them. You see that automatically my onDraw Gizmos, which is executed every frame, will use the last value that I set there. Alright, I do actually like these values. Do I actually? It's not quite far enough. So I'm gonna make it a little bit further. For site, you probably want some really big value anyway. So now we see that that part is what I want to happen. So this is only visualization for myself so far. So it doesn't really help me do anything yet. Oh yeah, I set color. You can do the same serialized thing with a color. So I will say Gizmo color, and the default might be red, but I could also change it. And then instead of setting the color to red, I will set this to Gizmo color. All right. Let's see. I see some chat, but it's no questions. Yes. All right. So what I see here now with the site component here is that there's also a color here that I can edit, and you'll see a change while editing even. So that can come in really handy. So let's keep it on blue for now. I don't know, it doesn't matter that much. You can use these gizmos, of course, while the game is running. If you, for instance, you can do this, like put the game view to the side of the scene view and open both at the same time, or just go back to the scene view while you're running. It doesn't really matter. This is where actually this aspect thing comes in handy here, because I can set it to whatever I want my game to run and it won't change. And I can put it somewhere. I could even put it there while it's running and still manipulate the scene while the game is running. Or I can just manipulate the scene while the game is running and see what's happening in the scene. In the scene view, then I can see those gizmos. There's also a possibility to draw the gizmos in the game view. That is a little bit different from the scene view. For instance, you see here that it's drawn over everything, while actually in the scene you see that it's occluded here by where it actually doesn't, where it goes through an object, it's semi-transparent. But it can be a handy thing sometimes to use gizmos in the scene as debug only, of course. Well, then next thing I can do now is actually finally implement the site to somehow detect things here. I'm going to start a little bit more simple. I'm going to start by first checking everything in a circle around me, in a sphere, because that's a bit more easy than checking this specific cone here. Yeah, one more thing about Unity. You've got two update loops, and that's if you implement any game engine at any time, then you will always see these two if it's done correctly. The fixed update is called every fixed frame. It's not a frame, it's actually, you call it a tick usually. So in Unity, for instance, the default frame rate is like 60 FPS that you aim for. Oh, hold on. That's project settings, I think. There we go. You see already that Unity is way bigger than whatever I show here. But you see here the fixed time step is at 0.02, which means there's 50 fixed steps every second. That doesn't mean there's maximum of 50 frames rendered, because that's the update. So there's update is related to graphics, and fixed update is related to physics and stuff. So things moving around. So if you're implementing anything for a game, then you always have to make sure that you put it in the right update loop. If you do something that's related to graphics, then you have to put it in update. If you do something that's related to physics and moving around, then you want to put it in fixed update. You can also increase the rate of fixed update, but in general, it's not needed. It just depends on what game you're making or simulation you're making. And then there's a start function. I'm not going to use it right now. I can get it back if I want to. It's kind of like the constructor, but there's no constructor here used here because the objects are made before the game is started. I'll show you that actually right now. It doesn't do anything now, but right now they are all inactive. They're not running their updates. If I do play, now they're actually all running their updates. There's nothing happening because there's nothing in the update yet, but you'll see once I put something in there. So here we go. Let's see what I can do now. And because it's all related to movement, because things move around and then I see them, it's based on the movement and not on the rendering. I'm going to put it in fixed update. If you do this in update, you have to make sure that you calculate. If you do stuff with time, you have to make sure that you use the time that frame actually took, because frames tend to take different amounts of time every time. So that's this is also why fixed update exists. It always has the same rate of updating. It's much easier to do calculations with that. Fixed update. I'm going to put here my my little site thing. So let's see what I need for this. I'm going to need to do the check, and I was going to first do a simple one, a sphere around my position, and that is called Physics.OverlapBox. And you see a lot of actually three possible shapes to test for overlapping, and one of them is sphere. All right, and I'm not going to go into the other one that's non-alloc, but it's actually much better to do that one. So just if you see this and you think, whoa, this is going to take a lot of memory leak and stuff like that, yes, it is. It's going to create a lot of garbage. But I'm not going to go into that right now. Collider, and I'm going to create a array of colliders, and I will call those the overlaps. And I'm creating it here because if I create it here as a local, then it will be a variable that's created every update. So I don't want to do that. All right, so this in overlaps, that's the result of this thing. That's what I could see here already. It returns a collider array. I compute and stores colliders touching or inside the sphere. So what I'm going to do is I put the position in here, the radius of the sphere, some kind of layer mask, and then if I want to use triggers, I'm not going to go into that one as well. But basically use this version. So I'm gonna go. That's the thing that I've used before. The transform.position. That's the position of this current object that this is running on. And then I want some kind of radius. Well, I already have my site distance. It's set in the editor, so I can use that one. That's the maximum distance that I will detect anything at. And then there's this layer mask. That's actually something I am going to show now. I am going to make a variable here that you can set in the editor. So serialized layer mask. And that one I'm not even giving a default here. but you can see it here now. And it's a lot of things about, it's mostly about performance. Now it will detect from nothing, but every object has a layer. So this one is on the layer default, but there's also transparent effects, ignore raycast layer, a water layer, and a UI layer. So basically all those things that I might include in my simulation or my game, I don't want to interact with. I'm going to add a layer here for instance, for the agent to be in and for the enemies to be in. It's handy to could call it agents, because I don't know how many there will be. It might be handy for later to have those separate. Also, the agent doesn't want to intersect with any other agent, maybe it does, but for now I only want it to detect enemies, but also the obstacles, which I will keep in the default layer. So you see here there's mixed, you can select multiple of these, it's layer mask, so that's like a Bitmask. You can select any of those and then you get a combination. So what happens here is it will use this mask to detect anything of those layers within the sphere that I'm throwing around this agent right now. The agent I'm going to put in the layer agents, and the enemies actually from the prefab I'm going to put into enemies. So now you see this changed here, so it also changed there. So now what the agent will do here, you see here the overlap sphere from this position with the distance that I set in the editor, so that's now 50, and then with the layer mask that I set here, so that's default and enemies, it will give me a list of all the colliders in that sphere. Well, we've seen that these things have box colliders and these things have capsule colliders, those are all colliders, so it should give me a list of those 7 objects. Let's see that. Well, how can I check that? I can do a number of different ways, but the most quickest one is just to print it onto the console, and I can do that, but not with a collection, of course. So I'm gonna go make a for each loop for each collider. Collider. I'll just call it collider in overlaps. That's the thing that I just got. For each of those, I'm going to say debug.log. You can also log an assertion or a warning, an exception, but I'm just going to log a normal log message. And the message will be, this is a C# formatting thing, by the way, a string, and it's going to give me collider.gameObject. That's a thing that refers from the, here we go, the component here to the object that it's on, and from that I can get the name. And I'm just gonna add little string there, but it's not even necessary. I could have just only logged the name. If I run this, I will get a lot of lines in my update, because it will find it, and it will find it every frame. So that's the next thing I'm gonna have to do, is be somehow remembering which ones I saw last frame and which ones are actually new. So if I run this now, you can see then the update starts, and you see this count here going up and up and up, and you see that it works. I get 1,000, more than 1,000, because it runs 50 times per second, and there's 7 of each, 7 objects found on each of those updates. And now it also finds terrain. So that's what I see now is, hey, that's not so handy. So what I want to do with terrain now, I want to put it on a different layer. Or do I? It depends. If I wanted to block things later on, it might be handy to actually keep it on there. But I'm going to have to ignore it later when I go reason with things like which one am I actually going to trigger something for. That's logic that you can do in a lot of different ways, but you have to think about it. So do I want to keep the terrain on that layer or not? Well, for this specific thing, I'm not going to change the terrain, so I can actually put it, for instance, to ignore raycast, and now it will not show anymore. So if I run it again, I've got all these things coming in, but there's no terrain among them anymore. All right. So what next? Well, first thing I want to do is somehow not find them every frame. And then I'm going to actually check if there's a line of sight with those raycasts. So first thing I do is the frames. So I'm not going to be able to do this properly if I don't check if I've seen it before. What I'm going to do for that is I'm going to make a collection of colliders that I use a hash set for. If you don't know what that does, I will not explain it right now. But it's a thing that only has one of each, and it's very easy to search for stuff. It's different from a list or an array because it can resize, but it can also only have one of each object. You can't have multiple instances of the same object in the hash set. So I'll have a hash set that I call inside. So that's for all the things that I have inside now. And then later on I'm going to need another one to check if they're out of sight. But let's see inside right now. Pardon. So here it's actually pretty simple. Whenever I get a collider here, I can put it in the inside collection. So what I'm adding is the current collider. That's super simple. Now this happens every frame, so it gets added again, and it can't do that. So this will return false, and it will just have the same one in there. No problems, no errors, but it's not so super handy because I want to know if it was already in there. So what I'm going to do now is add if inside contains the collider already, then I don't need to do anything. So I want to do it if it doesn't contain it already. Then I'm going to add it, and then I will add some debug message like found, cited, and then that collider. All right, so now I can spot them, and they should only turn up once. Oh, yeah, forgot one thing. I have to create the thing first, the hash set, and that's something that I will do in start, but actually a more early start. Start runs before the first update. Awake runs when the object is actually after the object is created. So I'm going to use awake. That's a little bit earlier even than start. Is new, so that's initialized. All right. Now I don't get these. It will automatically clear when I press play. It's also Ctrl P. And now you see there's only 7 logs here. Obstacle 4, obstacle 2, enemy 3, obstacle 1, obstacle 3, enemy 2, and enemy 1. So it does actually indeed return those 7 objects that are in the range of the agent. That's nice. But now I want to be able to also not see something anymore. So for instance, let's do it like this. If I go to the scene view while it's running now, if this agent would go all the way over here, it would have to not see it anymore, but there's nothing for that. So it will still think that I've seen it because it was added. So I have to find some way to remove them. Well, the trick is if I have one set and I put in another set what all the new ones are, then I can remove the new ones from the old set. Then I know which ones are left are the ones that I don't see anymore. I'm going to do that in code now. So last side or last inside, that makes it more clear. The ones that were last inside is actually the one the previous hash set. So I'm going to copy it. That I can do by doing this, I'm creating a new HashSet with all the things that were in that one. This is not per se the most optimized way of doing it, but this is more clear. So I'm copying all the ones that have been inside last frame, last tick, to this last inside one. Now that this one was inside, I already have like when I detect it, but now if it's not in there, so if inside does not contain this collider, if it does contain this collider, nothing happens. But at the end, I want last inside to only have the ones left that were last inside and not this frame. So whenever I find one, I will remove it from last inside. But I can only remove it from that if it is in there. Doesn't really matter actually, because if I do this, it doesn't give me any errors, because it just gives me a boolean if it succeeded or not. But I'm just gonna put it in here anyway. So, oh sorry, not in here, in here, else. So, oops. Basically, if it was inside, then I'm gonna remove it from last inside, so that at the end of this loop, last inside will only have the ones left that were inside last frame, but not this frame. Then for all those that were inside last frame, but not now, I have to remove them from inside. So I will do that for each collider. You can do this in a number of different ways, but I think this is fine. Collider, I'm gonna do it like that, and I will say in last inside. So this is going to go over all the ones that were last inside, but not this frame. For those, I will actually say I've lost sight of them. Well, actually, just copy this row, this line here. Oops, and then no longer seeing. And what I'll have to do there is I will have to remove those from inside. All right. So basically, what I have now is it should detect when it's inside, and it should stop detecting when it's outside, and it will trigger these lines, which I can use to do anything with later on. Not in this tutorial, but you can use these lines to put stuff like I'm now seeing this, so I will respond to that with an action. Let's see. Here we got, well, we see everything again, and now if I move this one, hold on, what? No, there. This one out of range, there, no longer seeing enemy one. No longed, typo. And then if I put it back in range, you see it gets triggered again. Seeing, no longer seeing, seeing, no longer seeing. All right, so basically by using this HashSet, I can check if it was seen at new or if it was already seen. So these are the points where you actually get interesting stuff to update your actual reasoning on. So first, from this you will update your world model, like your state, and then from there you can make decisions and act. Also, something you should not per se be doing every update. So only if something happens, you might want to change your state, and only if your state is changed, you might want to take action. But that could also be something that the act thing could also be something that you trigger every once in a while, like every second or something like that. But you don't want to do that every frame usually. All right, now the thing that I'm changing here, that I still have to change, of course, is that I want to see if it's actually in line of sight, because this one is not visible from this agent. It's not in line of sight. And that one is actually behind him, but that's a different thing. Let's first check line of sight. So now I want to actually do a raycast, and that's also something I promised to do here. So instead of just doing this for each collider that overlaps, I'm going to put something around this. So basically this bit will be in some kind of if. And what kind of if? It needs to have a raycast succeed. So what is a raycast? Physics.raycast. And I'm going to say not raycast all, because that will give me all the things that will go through array, but I want the first thing that's found in a specific direction. And that's what raycast is for. So it has a lot of different ways, but I'm going to use this one. The origin from which the ray starts, so that is the agent's transform.position. The direction in which I'm raycasting, that should be the direction from where the collider is at. So that is the point of the collider that we found minus the point where we are, will give the vector from A to B, from the position that the agent is to the collider that was found. So that would be collider.transform.position minus transform.position. And oh, by the way, some people like to use this, especially if they're used to something like Python, or just like the extra clarity to know that this is a class variable or a property. But in general, I like to just use code formatting, like color codes for that, and it's it's just a personal preference for any company, I guess, or team that you work in. All right, where were we? Oops. So that was the direction. Yeah, then I need an out, which gives me that's a nice thing of C#. You can say this will be written to by this function. So I'm actually gonna need a hit info variable. I'm gonna create that. So let me just create that. I'm gonna create it here, which is also in the class. It's also referenced, yeah, raycast hit hit info. I'm gonna create it here so that it's not like a new variable that's created every update again. And then we get the hit info, and I want to actually add the maximum distance here. So that is our distance, which we defined already, and then our layer mask. You see, actually it shows here int, and this was layer mask. That this is so that it can be set in the inspector, but it's automatically converted to an int there. Just a detail. So if this succeeds, then we have something. But that does not mean that what we find there is actually the object that we want to find. For instance, okay, so let's see. If this object, I cast a ray here, and then the raycast will succeed because there's an object in between where it starts and the maximum distance. But that doesn't need to be the object that I wanted. Oh, I see. This is why it looks so weird. It doesn't need to be that object. So I also need to check which object that raycast found. And that is where hit info comes in. So raycast will tell me if it found an object. That's the Boolean return value. But then hit info will tell me which object I found. So I will do if raycast found something, and then the hit info dot collider is actually the same as the collider we were looking for. Now we check if that is actually the case, and then we know that it's inside. So basically we changed from everything that overlaps to adding an extra raycast. Well, let's see what it does. I'll actually place the game down here for now. So I'm not really interested in that view, I'm more interested in the scene view. Alright, so we see, what do we see? 1, 2, 3, 4, 5, 6, where enemy 1 is not seen. That is nice. How can I actually make this more clear? If I add some more gizmos. Let me do that. I'm going to add some gizmos for all the, I'm doing this before I set matrix, because if you do it after that it will be weird. I will add a little line. Let's call that, let's always keep that very specific color. That is always, that's not something you find a lot, like magenta. And then I will draw a line from the position to any collider that I detected. So I have to put that in a loop for each collider. Collider in sight. So anything that is in sight, I will draw a line to the collider's position. Well, there we go. Now this one should, while running, and now we get errors, I think, because yeah, there we go. Insight is of course not set now. So I'm gonna say if it's running. I could do this a number of different ways. I could do if application play state is playing. I could do that. Or I could do if insight is not null. But I have to add something to not do this while we don't have any objects. Just like I said before, update will only be running while it's in play mode here. Well, this is, I can clear it. There's nothing happening right now anymore. Save, and then let's see what it does. Now you see these are all the objects that it sees, and there's no line to that one. So let's see what happens. If I move it, there we see, and you see sighted enemy 1. And then if I put it behind the obstacle, boop, no longer seeing enemy 1. Let's go here. Yes, seeing it. And now we actually want something else here. This is interesting. Huh. I don't know what's happening there, but that's probably because I'm moving it in the scene view. Oops, wrong direction. But basically, this works. So the only thing that's left here for the site is to do it in that direction. And then we can talk a little bit about different types of modalities, but basically you just add some kind of tag to it, and then you do it in different ways. For instance, for sound, you can just use overlap sphere and then check if there's like big objects in between, but you don't really even have to do that. Like for sight, you have to do these raycasts. And for touch, it's even different. But actually for touch, you can just use this overlap sphere, but then with a small sphere. And if it's near enough, then you could just say it touched. But let's finish this in the complex way first. And that's what I have this thing here for. Whoa. No. That's not so handy. There we go. Okay, yes. This ConeCast thing, I have that. It's made by someone else somewhere in the past, and I adapted it. ConeCast, because you got a sphere cast in Unity that gives you a sphere around a ray. So everything that hits that sphere that's moving around that ray will be included, but you don't want everything. You want it only in the cone. So I add this ConeCast script here to be able to do that, and I'm not going to go over that completely, but I'm just going to use it now. So instead of this overlap sphere bit, I'll keep with the Raycast thing, but instead of the overlap sphere bit, I'll just comment that for now. Then overlaps, I also need to comment, actually put it there where I use it, because it's a class variable. It's something you can or cannot do. depends what you want. And then of course this for each loop will also need to be different. So what am I going to do? I'm going to use ConeCast.ConeCastAll. I will give you this ConeCast script, by the way, and I'll give you the original link as well in the description. So basically, from where? Well, origin is the same thing again, transform.position. And then where to, like max radius. And max radius is a bit icky, because I'm not giving it the angle, I'm giving it the maximum radius that the cone goes to. What is that? Well, fortunately, I've thought about that as well up front. So this is our situation. You got the NPC, or like the agent, and then you have you want the radius of the cone that you're casting, and I know the angle and I know the distance. So basically what I have to do is I've got to think about half the angle there and the distance to get me a SOH-CATOA situation where tangent divided by the opposing the tangent is the opposing side, and the other side, I don't remember what it is in English. Well, so you get that one that we want divided by distance is the tangent of the angle divided by 2, and then the tangent of the angle divided by 2 times distance will be the one that we need. So that will be the radius of our ConeCast. Right, so that we can do. And we don't want to change our angle while we're going at it, so I'll just add a class variable here, float, what is it, cone radius, and then that can be calculated only once when the object starts, so in a wake. Cone radius is now and that's a special floating point value of math. I think it's not really needed. I get the tangent of the angle divided by 2, and this I will multiply by the distance, and then I have the cone radius. Now this is a problem because angle is not in radians but in degrees, so I do have to multiply this by and there's a nice helper for that, degrees to radians. It's a specific number that you can multiply it by. Alright, so in radians the angle, and then we've got the cone radius that we want to cast. Okay, finally we can put it here. Oh, jeez, there we go. So a cone radius, the direction we already know, that's transform.forward. And what is transform.forward? Again, that's just the z-axis, the blue axis. So again here, that one, that's forward, that vector. And then the maximum distance, we already know that one as well. And the cone angle, that's for a different calculation. There we actually can use the angle. Now this doesn't give me a collection of colliders, but it gives me a collection of Raycast infos. And yeah, that's just what it does. So I will have one of those instead. A array of Raycast hits, and those are the cone hits. I don't know, cone hits. Come on, cone hits. And then, so we say cone hits is that hist hits, just like this one actually. Where was it? No longer seeing. Cone hits is that, and then I have to have some kind of if. So if cone hits for each, and then it's not that's a Raycast hit, cone hit in cone hits. Now I don't have the collider yet, so I have to do it differently here. I need the collider from the hit, which is simply available. I will make it here. Collider. Collider. I can't use it there anymore. I can, of course. Yeah. And now collider is, as this is not descriptive enough, I'll change it. Is the cone hit dot collider. I'll actually change it here. Control R to rename collider, and it will be the cone hit collider. There we go. So for every one that the cone hits, I will take the collider and do the same thing as before. Well, let's see if it works. If it works. That was PowerPoint. There we go. Is it not running? It is running. Oh, my ConeCast is not working. All right. Oh, there we go. That's strange. Huh. I did something different than before when I was setting this up. Raycast from the position. That's okay, but then ConeCast. Cone radius, direction, next distance, cone angle. It looks like the direction is not taken along here. Is that true? Oh, and not the enemy, the agent. Let me. Oh, it is. Oh, it's just smaller then. That's strange. It's not the exact direction that I was looking for. That one is, but that one isn't. That's quite intriguing there. That one is actually behaving the same way. So that the box is doing all right. It's actually not. Huh. That's quite strange. So I'm guessing that something went wrong there with the specific distance, cone radius. Did I do something wrong here? That's interesting. I don't see it at this point. I will put it in the I'll put it in the description later. Right. This is the basic way of doing something like that, and just because it's not it has some weird offset right now doesn't mean it don't work, because right now this still follows and that works if it like behind something, so most of it works. It's just something weird with the ConeCast, I guess. All right. It might also be in the ConeCast script, something I didn't notice before. But basically it doesn't see something that's behind it unless it gets in front. And also, well, they can block each other, that's also fine. This is basically maximum what we need for detecting stuff, and the HashSet thing is also very important for doing the events at the right time. I will actually show a few little bits here that can be handy for this, and then we'll leave it at that. So one thing that I started before was Modality. I actually don't want this to be a class. I want this to be a enum. And enum is just a number of numbers that you give a specific label. and this all goes away. That's boilerplate from Unity. Modality, I can create an enumeration of modalities. So I can say sight, I can say sound, I can say touch, and I can say smell. For instance, those could be modalities in a simulation. Also, I maybe want something to be able to, just like we've seen with the layers, be able to do sight and sound or something like that. So, some enemy, for instance, can be seen and heard, but not touched or smelled, or something like that. For that, I've got the flags attribute that I give to modality, and that tells us that we will use these as binary flags, binary so bits that I can use. And for that, I will give them each a power of 2, so that this is the first bit, this is the second bit, third bit, and fourth bit. I could also write this as as this, one with 0 bit shifts, one with 1 bit shifts, one with 2 bit shifts. If I don't want to calculate the powers myself, especially later on, this is easier if it gets to like the 8th or 9th or 10th power and you don't want to look them all up. I could give this site class now a constant modality. I could actually rename it to perception modality. You might want to do that. And it's going to be a constant, so it means I can't modify it. It will just be compiled in, and that one will be a constant modality, modality, and that will be modality.site. That way, if I do something with this class at some point, I can look up its modality just by that specific enumeration, and I could switch on it or do some other things with it. Filter, most likely. So basically in the agent class, you would, for instance, say that it needs to update its site, and you can like refactor that. Collect all the stimuli. Let's see what the handy way would be. Yeah, for instance, I'll just show that one a little bit here. I would create a reference to the site for this specific agent, and then I can in the agents fixed update. Yeah. In the agents fixed update, I can check the sites, the ones that it has, what was it, inside. For that, I will have to make it accessible to agent. I won't make it public. I will instead change this to 2 different lines. Last inside, I want to still keep private, and inside, I'm going to make internal. That means it can only be accessed in the same namespace, in the same assembly. That's just a thing. Well, in this case for Unity, you could just use it in the project itself. It's not super safe for if you're gonna make something complex with a lot of people, but then you might want to use namespaces after all, and then it will be something super handy. So now I can use inside, and then I can do some stuff with that. So collecting for each collider, and I could do stuff. A handy thing of Visual Studio, by the way, put to do there. A lot of IDEs do that. And you get a task list. You can use task list to do. And it's over there. It will automatically collect any to do in a comment. So that's what you could do. And this would be probably in some function that would be the like update your state, update state, something like that. It's called update often in agent terms, and then you would do that at some point, and then after update state you would reason some kind of reasoning, and then you would act. Ooh. And I'm not going to fill those in, of course, because those are beyond the scope of this this tutorial. But based on the things that you've seen, you can collect all kinds of info and then say, okay, I've seen an enemy, so I want to remember that, and then in my reason I can reason with the agents, the enemies that I remember, and then I can act, for instance, go toward them or shoot at them or whatever you're doing if that's a game, or evade them if it's like a simulation for viruses or whatever you're doing. It really depends on what you're doing there. So basically that's the way the agent would use the site, and you still have to give it a reference though. And that's a very funny thing. This doesn't have a reference to the site thing on the agent itself. There's a piece of code that I could use. If I would say in a wake, I could say site is GetComponent, and then you get the component on the same object. But that takes a little time to do. You could also already set this reference. Oh, by the way, never use GetComponent in an update loop because it's not that cheap. It has to go through all the component things on this object. I could also just drag this thing in here, and then it automatically already has a reference set up once you launch it. So now this site thing will already be linked to this site instance that the agent has. Yeah, that's a lot. Let's think. Maybe there's other things I want to quickly go over. Yeah, let's do two more things. One is triggering events in the C# way. That might be a nice one to know of. And the other one is how you would make a spawner. So you would spawn items, you would spawn objects or enemies or stuff. So the first one, the events. So basically, you would see how for sight I could use this, and then for smell or for sound, for instance, I would use that code. And also I could make a superclass that is like perception, and sight would be a subclass of that, so it would be nice and reusing a lot of things so that I don't have code duplication. But apart from that, the events, this part here, I could actually now use a C# event. So basically what I'm going to do here, I'm going to put that in here. So the agent on start, so I'll use awake again, will subscribe to the events of the site part. And that is there's a specific way of doing that in C# that is very elegant. I always have to think about it properly. But basically there will be an event here that you can subscribe to. So I will yeah, I'll have to quickly take a peek at the way this is done again, but let's call this on enter vision, and let's think. There's a type that I need to have, and that is an event delegate. Oh, right. Just gonna quickly look that up. C# event. I don't do that a lot because it's usually in the there we go. No, there's no standard event args. All right. Yeah, so I'm putting another class in this file. That's might sound weird to some people here, but vision event arguments, just like you see it here, and that will have the specific arguments that you can use for a vision event. And in this case, it will be a collider, and maybe some other things, but this is it. I'm gonna have to make that public. So vision event args Oh, it needs a handler. Yeah, of course. Vision event handler. And I have to create a delegate for that. It's just a lot of syntactic stuff. So you see here, you need to create a delegate. You can look up what that all means, but I'm not going to explain that in detail here. But just use this pattern if you like, and you don't even have to know what it means exactly. So there's a vision event handler, and just like this, it will use an object that is the sender of the event, and then the event arguments that I need here. So vision event arguments args. So basically what you declare there is the type of pattern that you're using to send a specific event. So onEnterVision is now a event handler that will be able to like get subscribed to. Well, I'll show you what that means. So for instance, I'll make a function here that's called onVision enter, and that's for the agent. And then it needs a collider, but that doesn't work like that. Oh, hold on. I'll actually let Visual Studio generate it. That's also easy to show you. Site.onEnterVision, and I'll just use +is, and I can use tab here like Visual Studio suggests here, and I just poof, have that created for me. I can also rename it. OnEnterVision is enough because site is already showing me that. And here you see you get the sender, like which object, that is always site. So in this case, it's not that interesting, but you get the event arguments. And that one, I can actually now paste my debug info and it will still do the same thing. So now it's the agent that cited it. So I'll use the name of this game object name has cited, and then the args will give me the collider. So now what happens after all this mumbo jumbo? Site still does its thing here, but it will, and there we go, onEnterVision.invoke. Because we use invoke here, we have to give it the arguments. So this object is invoking it, and then there's a new vision event arguments with collider being cone hit collider. So what I do here, this will create a vision event argument object where we pass this or any other data that we want to give to any class or any object that has subscribed to this event, and the subscription is done here. So in here you say I want to receive onEnterVision events. So as soon as onEnterVision is invoked, anything this one, as soon as onEnterVision is invoked, then let's not call them the same because it's just, this is more clear. Something enters the vision, so onEnterVision here invokes anything that is subscribed, and this thing has subscribed here, so this call gets called then and will say agent cited that thing. Same goes, I could do exactly the same thing for no longer seeing. Then it would be on leave vision, and we don't have that yet, so I'll make that one as well. On leave vision, vision. Not much more I need to do there because it has the same arguments, so I can just use the same pattern here. Site.onLeave vision, and then I make leave vision. I actually make them different so it makes a little bit more sense. Entered vision and left vision. So if onEnterVision is triggered, then we get left vision called, and left vision does the same here. This agent site no longer seeing. I'll just remove those. Okay, so now you'll see that these get called by the event chain. There we go. Yeah, they are. That weird thing is not working perfectly. There we go. Agent cited enemy. So what you basically, enemy 2, what you basically see here that is that it was called from FixedUpdate. You can see the stack of calls here. FixedUpdate inside. That calls agent entered vision. So that's this one. And there the debug log is done. And the same goes for left. No longer seeing. If I move this obstacle, whoop, same goes for enemy 1. Now, of course, you want all those things to run around and do stuff. You can use a rigid body for that to have the physics engine handle all kinds of movement, or you can just update the position in FixedUpdate. I could simply show, like, for instance, transform.translate. Oh. And I will do a little translation. Vector 3, let's say, how much do I want to move it? Well, it does 0.02 per tick. So let's move it 1. This just means 1 unit per second. But instead of this, I can also use Time.fixedDeltaTime. And that's the same one. But then if you change it in the engine, it will still have the same rate. So now it will move 1 unit. The thing itself is 1 unit. So we'll move 1 unit in the x direction per second. So it probably will move there. And why does it move to the right? Well, you see its x direction is there. So that's the way you can move stuff, and then you can do all kinds of things with where you want to move them, but that's up to you. That's, again, not in the scope of this. This video. Last thing, as I said, I want to do is show you how to spawn some stuff. That's something you want to do from a different object. For instance, a enemy spawner and a me spawner. And then I will just make a script called enemy spawner. And then I can actually spawn some enemies instead of them just already being in the scene. So I'll remove them. And now I will spawn them. And this I will do. Well, let's keep it simple for now. Yeah, actually, why not? I will. It doesn't really matter if I do this in update or FixedUpdate, but since I'm doing the other movement in FixedUpdate, I'm doing this here as well. I will. This is one thing you can do. Just create a little timer that updates every frame. Then you can just use Time.fixedDeltaTime again, and then this timer will tell you how much time has gone by, and then I could say, like, if some kind of spawn time, and I could set that, for instance, to 2 seconds, and then if the timer has passed the spawn time, then I will spawn something. I will put the spawn time back to 0, actually remove the spawn time so that any non-exact rounding thing will be negligible, or will be subtracted. So if the timer is just over 2, it will still nicely tick every 2 seconds. But the spawning itself is going to happen there. For that, I'll need a reference to the prefab that I made. Well, I know how to make references. I do that with serialized field, and then I can drag it in there in the inspector, like I've seen before. So I will, what am I going to spawn? I'm going to spawn a game object. That's the basic thing that is on every object is a game object and then has components, those mono behaviors that you see. And now, so game object will simply be a reference to some prefab that I'm making. So I'm going to call this enemy prefab, and then spawn enemy I will use this function instantiate. I can't just do new something because it has to read that whole prefab and make every bit of that the components that are on that prefab and set it to the right settings and stuff. So that's where instantiate comes in. You have all these different versions of it. It doesn't really matter. In this case, it's going to automatically instantiate, but now it will just put it at 0, 0, like in the middle. The normal thing I want to use is this one, where I give it a position and a rotation. So now I could, for instance, use the time that has elapsed since for instance, time since level load, and I use that to rotate it around some kind of point, but really doesn't. I could use that to rotate a specific point. Yeah, let's do that actually. No, let's do a nice other one. Random. Random in Unity has a lot of different things. I can, for instance, use random inside unit circle to get, sorry, not inside. I want it on. Random on unit sphere. Oh, that's not so handy. Oh, actually, random inside unit circle and then normalized will give me a point on a circle. So this thing gives me a point on a circle. I can't do that at once here. So I'll get a, it's not, oh, you'd have to put this outside the loop, but I'm just finishing up here. Circle position is that one. And then what I want to do here is instantiate the Y position will always be 1, as we know. So it's the X position of the circle that I just had, and then 1, and then the Z position. Sorry, the Y position is where we put on a Z. And now I have to only give it the rotation, and for that I'm going to use quaternion.identity, which means no rotation. This one is pretty important. I'm not going to let it run for long now, because then I'm going to get a lot of enemies just through each other, but let's see what it does. So here I have to put the enemy prefab. I can just drag it from here, enemy, whoop, and now it knows what prefab it needs to instantiate. Oh, whoa, whoa, whoa. Okay, I did something wrong here. Oh, spawn time minus spawn. Oopsie. I wanted to subtract that from timer, of course, not from spawn time. And there we go. And every 2 seconds you see a new enemy being spawned. It's quite close there. So let's just say I want to give this a different location a little bit further away. So I'll do times, I don't know, 30 or something. And then also I want to give this thing a different name. So this returns a game object, and for a game object I can simply set its name. Enemy. And then I can make an incrementally changed integer num enemies. Starts at 0, and I increment it before I use it here. That's a nice thing. You increment before you use it is plus plus before. Nice C# thing again. And there we go. Enemy 1, enemy 2, where are they? Ooh, there. That's not good. Where did I put that? Oh, everything times 30. I should have put that here. Now it was also putting a Y for 30, so up in the air. And 2 seconds, and every 2 seconds we get an enemy. And you see that it already cites one that is actually put in its thing. So if you want to spawn a lot of the same times, just the same thing, just keep spawning them. All right, I think that should definitely be enough for this extended tutorial. The most important thing being like how to use that sight, smell, and stuff like that. Just put more of them on here. So if you make smell, you can put that one on as well. And then you make a reference in the agent, and then you're subscribed to the events, and then you're set to go. Yeah, that wraps it up. I'm hoping that this would definitely have been useful. Yeah, if you like this, absolutely drop a little like there. And if you want to see more of this kind of stuff, then also subscribe, of course. We're going to make more tutorials than just the Git ones that were on there right now. Maybe there are more when you're actually viewing this, but trying to do more of those. And maybe some more of these long forms as well, but also some more scripted short videos, like, for instance, the one about flat and smooth shading. There we go. All right, so the music that you hear is also a nice one that we have made for our upcoming game, Outranked, which we are still testing, so join the testing for that as well. And well, I hope to see you in the next video, I guess, like some nice YouTubers say. Thanks for watching, and see you soon.